research scholars, students, and state officials. Thank you for joining today. Uh, this is Dr. Maneesh Jaiswal, working as a director in Central Water Commission, and a warm welcome to all our esteemed listeners who are here. And today, I would like to invite our one of the distinguished speaker, who is Professor SM Yadav, who is a professor in Civil Engineering Department, SVNIT, Surat, Gujarat, India. And I would like to thank him. He has agreed to deliver lecture to our listeners. And before moving ahead, I would like to make this lecture a bit special today, because we all know today is a Women's Day, and the whole world is celebrating this. So we are having one special guest among us, Miss Swati Kausal. Warm welcome, Swati ji. She is working as an officer in Canara Bank. I thought who would be better to start with, when someone is special working as an officer, she can deliver something. So on the occasion of Women's Day, I would like to invite Miss Swati Kaushal to give a message to our community on behalf of women's fraternity, and so that we all can listen her. Welcome to Swati ji. Over to you, please, kindly.
So thank you so much. Thank you so much for inviting me in this platform. दोस्तों कहते हैं कि खूबसूरत एक पल का किस्सा बन जाता है खूबसूरत
वॉइस आपकी थोड़ी मिस हो रही है, स्वाति जी, आई थिंक.
Now am I audible to you, sir?
यस यस.
हाँ. दोस्तों कहते हैं कि खूबसूरत एक पल का किस्सा बन जाता है जाने कब कौन जिंदगी का हिस्सा बन जाता है कुछ खास लोग मिलते हैं जिंदगी में जिनसे कभी ना बिछड़ने वाला रिश्ता बन जाता है आदर अभिनंदन आभार नमस्कार आदाब एंड सत श्री अकाल हेलो एंड अ वेरी गुड मॉर्निंग टू ऑल लेडीज एंड जेंटलमैन प्रेजेंट ओवर हियर a very warm welcome to this absolutely wonderful and auspicious day that brings together so many special people like you all. I'm Swati Kaushal, your host and those for this beautiful session today. दोस्तों पहले मैं शुक्रिया अदा करना चाहूंगी मनीष जी का जिन्होंने मुझे मौका दिया इस प्लेटफॉर्म पे मैं कुछ बोल सकूं सो दिल से आपका अभिनंदन और आभार है and first of all a very happy international women's day to all the beautiful ladies present over these sessions so I welcome you all in this beautiful event today कुछ थीम बताऊंगी आज का महिला दिवस पे like this year the theme for 2026 women's day is leading the change women shaping a sustainable future महिला दिवस के तो कई नारे हैं जो सशक्तिकरण समानता और सम्मान पर जोर देते हैं जैसे सशक्त महिलाएं सशक्त समाज का आधार है शिक्षा ही शक्ति है नारी की महिमा अपरंपार है हर साल थीम बदलती है लेकिन मूल संदेश यही रहता है कि महिलाओं को आगे बढ़ाना है और उनके अधिकारों का सम्मान करना जरूरी है ताकि हम एक बेहतर और समावेशी दुनिया बना सके So on this special occasion, I again, from my bottom of my heart, I wish you all ladies a very happy International Women's Day. कुछ lines और बोलूंगी, especially on the focusing on the women only. The hand that rocks the cradle, the procreator, the mother of tomorrow. A woman shapes the destiny of civilization. Such is the tragic irony of fate that a beautiful creation such as a girl child is today one of the gravest concern facing humanity. Girls have the power to change the world. It is a fact. So Manish ji, once again, thank you for giving this opportunity to be a part of this session. And once again, happy International Women's Day to you all. So Manish ji, it's over to you. Thank you, sir. Thank you so much.
Thank you, Ms. Swati, for this wonderful, message to our community, and very much grateful to you also that you have agreed to give your time for our listener too. Thank you very much, Swati ji. And now going to our next process, I would like to invite Professor SM Yadav, sir, who is working as in civil engineering department, SVNIT, Surat, Gujarat, whose title for the today's lecture will be Ensemble Forecast, Unlocking Hydro-Meteorological Insights. Hope Professor Saab, you are here, you have joined. Sanjay Saab, SM Yadav Saab, are you here? Sir, आपकी वॉइस
Hello.
SM Yadav Saab.
Am I audible?
Yes, you are audible. Please, you can
Okay.
start and over to you, sir.
You have to allow me to share screen.
Yes, I think you might have been allowed. Please try.
For being a passion time. It's my pleasure to be a part of this session. It's my pleasure to be a part of this session. Thank you so much. दिल से आपका अभिनंदन आभार. दिल से आपका अभिनंदन आभार.
पूर्ण કર્યું તું ને કઈ રીતે? Sir,
You are audible. Are you able to share?
able to share.
Please.
Hello. Sir.
संजय साहब बताएं.
Hello.
Sanjay साहब, I think you have changed the device now. We are allowing you. Just a minute.
Sanjay.
Now you can share, Sanjay साहब.
No, sir.
Unable to share still.
No. મારામાં નથી આવતું. સ્ક્રીન આવે તરફ દેખાય છે? એક મિનિટ. પીપીટી દેખાય છે હવે?
नहीं, अभी तक दिख नहीं रहा आपकी पीपीटी.
1 minute, I'll be rejoining, sir.
Okay.
Now I can share. 1 minute.
Okay. Just a minute.
Yes. Now I'm able to share. So I hope my voice is clear and PPTs are visible.
Yes, you are clear and loud, and your PPT is also
Thank you.
clear and loud.
Thank you. Thank you so much. Thank you so much, sir, and thank you for nice words on the occasion of Women's Day. I greet all the women participants, girl participants who are attending this particular webinar. I thank Maneesh ji for giving this opportunity. This is a nice initiative to connect the community which is working in the area of water resources and climate change. Ensemble Forecasting, Unlocking Hydrometeorological Insights. I'll be going to talk about how Ensemble Forecasting can be a future tool for mitigating the floods. So one can cite this presentation. I'll share with you also. At the same time, it will be shared on YouTube as per the practice of this particular group. So whenever you use any of the content of this particular presentation, you can cite this accordingly. You know that water in abundance or scarcity is the one element that connects 90% of disasters around the world. This was by Mami, Special Representative of the UN Secretary General over the disaster risk reduction. The floods in India that that was common, and since last decade, that is after 2010, this has worsened. And these are some of the pictures which sees that one or other part of the country that was moving towards the state of Gujarat, and the another depression which was formed over the Arabian Sea, that has also simultaneously moved over the state of the Gujarat. And because of that, the Banaskantha, Dantewada and Abu region received 1473 mm of rainfall just in 48 hours, that is between 23/7/2017 and 24/7/2017. You can imagine the average annual rainfall of this basin is 921 mm, while this on these days, that is 23rd and 24th 2017, 1473 mm of rainfall was received by this Banaskantha river, where the Banas river originates. This rainfall was of an extent of 1 in 112 years of written period, and such type of events are globally increasing. This is the map which shows that this is the Mount Abu, that is the hilly region which has received very heavy rainfall on 23rd and 24th July of 2017, from where the Sipu river originates and the Banas river originates. There, on both these rivers, there are two dams. One is Dantewada Dam, as shown over here. Another one is that is of the Sipu Dam. And on the downstream of the Sipu river and on the downstream of that of the Banas river, both confluence is approximately 10 kilometers from both the dams at this particular location where one town is located. So what happened, that because of such heavy rainfall in this region on 23rd and 24th of July 2017, it has been found that the both the dams which were on this particular river, they were almost full. I'll come back to you to those figures later on. So this was the inflow hydrograph of Dantewada Dam on between 23rd and 27 2017. You can see here three lines. One is a blue line, another one is outflow orange line, gray line is our dam level, and green line is our rule level. Rule level means during the month of July, the dam can be filled up to this level only. Okay, so what has happened, you can see over here, the blue line is your inflow. On 23rd midnight, the inflow started into the dam. Okay, and suddenly on 24th midnight, as I said, because of such a heavy rainfall, the inflow shoot to right from 10,000 or 15,000 cumac to that of 260,000 cusacks at in a very short duration. That made the dam authority to start releasing the water. What was the condition of the dam? So you can see the gray line, which is the dam level, and you will find that the dam level started increasing from 23rd midnight to that of the 24 midnight up to the rule level, that is 182.5 meter, while the full reservoir level was 184.1 meter. Even you can see that on 24/7 the inflow was so high that it has crossed even the rule level, right? And the dam authority, you can see over here, the dam authority started releasing the water, which was 0 cusack to directly around 2,25,000 cusack just in few minutes. Means they have opened all the doors of the gates of the dam, and that has they have started releasing the water. So this was the condition of one dam, which was Dantewada Dam. At the same time, the Sipu Dam, which was also received heavy inflow because of such a heavy rainfall. You can see that on 23rd the inflow started into the reservoir, and even it has gone up very close to that of the full reservoir level at the same time, that is 24th at midnight, right? So to safeguard the dam and to maintain the water level, you can see the green line is 182, that was a dam level, of that particular month, rule level of that particular month, and this gray line shows the water level, dam water level, because of inflow into the reservoir. In this case also, the dam authority forced to release approximately 250,000 cusack at the midnight of July 24th July 2017. So as I have shown you in the earlier figure, that these are the two dams. This is Dantewada Dam, this is Sipu Dam. Both the dam confluences on the downstream side. Dantewada Dam released approximately 225,000 cusack. Simultaneously, the Sipu Dam released 250,000 cusack. At the confluence, it becomes 475,000 cusack. Now, what is the condition of the river? That you can see over here. This is the picture from the Dantewada Dam downstream of the river. This is the picture from the downstream of the Sipu Dam. And specifically, I will show you the picture wherein you can see what is the depth of the river. If you will see the downstream of these two dams, the depth of the river you can see just from the bank and that of the river, and this pole is there in the middle of the river. You will see hardly there is a depth of 2 meters to 3 meters, and there we have released the water of around 475,000 cusack. What will happen because of this? As you are releasing such a huge volume of water on the downstream side, it has made the disaster. As you can see here, that this is the river downstream of the both the dams, and moreover, there is a Narmada main canal which was perpendicularly carrying water from Narmada Dam to the various part of Saurashtra and Kutch region. This is a contour canal, and this particular canal was partly above and partly below the ground. So the water which has released from the dam, right, that has started moving right on the downstream direction like this, right, as I am showing by the pointer arrows like this. And this canal which was partly above and partly below the ground, that has become a obstruction for the water to pass, because there was only one siphon over here which was 750 meters of land. So entire 475,000 cusack water has to pass from this particular siphon, right, which was not sufficient to allow 475,000 cusack water to pass through this particular siphon. So because of that, what has happened? You can see here, this is the Narmada main canal, the photo 2 you see, and in photo 2 you will find that this picture, photo 2, yeah, this is the ground, this is the canal, and you can see from the ground this is the height. So this particular part is partly above and partly below, as I said, and as the water hit this embankment, it has washed out this particular embankment. The other picture you will see over here, where a considerable length of the canal that was breached. So this water breach approximately 25 kilometer length of the canal, and you will see that downstream side of the these two dams heavily flooded. The roads get washed away. The village is submerged, inundated in the water. These are the villages which are on the downstream side of this particular rivers, these particular dams. They were inundated, and the damaged picture of canal again over here. And this is the NDRF team rescuing people from this particular area. So the entire study was modeled and a map was prepared, and it has been found that from the either bank of the river, the water has spread approximately 5 kilometers, 2 to 4 kilometers on either side of the river. Not only that, the siphon aqueduct was not sufficient to pass the water which has been released. This is the dams are over here and here. So the water is released and flowed over here. the entire path. So these are the number of villages which were submerged under the water, and those which were very close to that of the Narmada main canal, they were worst affected before the Narmada main canal breached. Because after the Narmada main canal breached, the depth of water reduced in the some of the villages which were very close to that of the Narmada main canal. Okay, so this resulted into the loss of 1,653 crore, cattle loss of around 14,300, and the approximately human life lost in this particular flood was 200. So this shows an example that how the climate is impacting the monsoon, the pattern of rainfall, and as I said, short duration, intense rainfalls are increasing globally, and the similar events are observed in our country too. So what is the motivation? So weather extreme increases, floods, droughts, compound events, deterministic forecast, inadequate for uncertainty. As we have seen that there was the forecast which was there for receiving the water or rainfall maybe of 24 hours before, as we have a traditional forecast, that is deterministic forecast. So why I have shown this, that I will show you further after discussing the few slides, right? So what is the objective of this particular presentation, today's presentation? So to provide a comprehensive understanding of ensemble forecasting techniques and their application in hydrology, aimed at enhancing the capabilities of Indian researchers and professionals in this particular field. So before I start talking about the ensemble prediction, let me explain you the very basic thing which is associated with that of the ensemble prediction system, that is numerical weather prediction models. So what are numerical weather prediction models? Numerical weather prediction models are computer-based simulations that solve complex mathematical equations based on physical laws, that is fluid of motion, thermodynamics, etc., to forecast weather. By analyzing current observational data, that is satellites data, radars data, observed data on a 3D grid, they predict temperature, precipitation, winds, etc., using multiple perturbed initial conditions. So what is the concept of ensemble forecasting? Ensemble forecasting is a method in numerical weather prediction. Instead of making a single forecast, what we do, single forecast of the most likely weather, a set of forecasts are produced. This set of forecasts aim to give an indication of the range of possible future states of the atmosphere. Ensemble precipitation data refers to a collection of precipitation forecasts generated by running a weather prediction model, that is NWT, multiple times with slightly varied initial conditions or model physics, and that generates a set of forecast predictions, right? So when we talk of EPS, an ensemble prediction system is a weather forecasting technique that involves running multiple simulation of a weather model with slightly different initial conditions or model configuration. This helps estimate the uncertainty in the forecast and provides a range of possible outcomes. So in a graphical manner, if you want to understand what is the ensemble prediction, you can compare it like this, that if suppose you have a initial condition, you are giving it to the model, and that model gives the forecast, but that forecast will not be the one, but it will give you range of forecast depending upon how many initial conditions you input. For example, if I am inputting 50 initial condition, that is 50 ensemble members, that is given to my model, and that model will give you the 50 ensemble predictions, right? So that will be the range from maximum to that of the minimum possible precipitation over a particular period, right? So what is ensemble forecasting? Uses multiple perturbed initial conditions, produces a distribution of possible outcomes, captures uncertainty in weather prediction, and essential for that of the hydrological extremes. When we talk about the ensemble forecasting, the concept of ensemble prediction system, right? What are the various how it sees. So you can see when it is a deterministic forecast, it is shown in the left hand side graph, that is a forecast and what may be the observed values. But in case of ensemble prediction system, you will not have any forecast from a range of that of maximum to the maximum to a minimum, right? So this has been shown over here. When we talk of ensemble prediction system, how many such systems are there who are producing this particular data, who are producing such type of a forecast? So there are n number of centers working over the globe. Out of them, some of them I have listed in this particular slide, wherein ECMWF, that is European Center for Medium Range Weather Forecast, the system name that ENS, that is medium range, and it produces 50 ensemble members. When it is written 51, that means that one control forecast and 50 ensemble members. Likewise, we have NCEP data, we have UK MAT, that is of UK data, CMC, the Meteorological Services of Canada, Japan Meteorological Agency's data, JMA. There, when we see this centers data, the question comes into our mind, what about India? Do we have any center which produces the ensemble forecast? Yes, we have two centers. One is, that is NCMRWF, that is National Center for Medium Range Weather Forecasting, India, which have a 22 ensemble, 22 members total, one control forecast and 21 ensemble forecast. This is the pictures of the NCMRWF Noida unit, which is developing the medium range weather forecasting. And these three students, they are my research scholar, this Anand Patel, Ayushi Panchal, and this is Rashmi Yadav. They were working on the ensemble forecasting. And this is Dr. Ashrit from the head of ensemble prediction system at NCMRWF Noida. This is the one center. They have a supercomputer which generates, which collects lots of information and lots of data, satellite data, radar data, observed data, then gauges data, all right, weather station data. All these data are collected by this particular center, and they change certain initial conditions, feed it to that of the supercomputer algorithms that produces the range of the forecast for how many parameters, that we will see in the next slide, right? So this is again the another one which is IITM Pune, which produces GFS data, and it will also be available on a global platform as IMD. So this NCMRWF data is available as NCMRWF data, and IITM Pune data is available as IMD ensemble data at the global platform, right? So this NCMRWF developed highest resolution ensemble prediction system for short range prediction at 12 km using 11 members of the model. The NEPS prediction system provided probabilistic rainfall for next 10 days. They used assimilation system of UK Met Office hybrid 4D version. The initial condition perturbations are generated by ensemble transform Kalman filter. Similarly, for IITM Pune, GFS data of 12 km, 20 members has been generated by that of the Pune. These both the data are available at a global platform also. At the same time, any of the research scholar or any of the practicing engineer wants to have this data, they can write to either NCMRWF or IITM Pune, and they will provide you the data. So which is the national or international platform from which we get this data? So it is called as TIGI, that is Tropics WMO initiatives, which host the ensemble data of various agencies which I have shown you. That is, out of that, ECMWF, one of the oldest ensemble prediction system of Europe, which is more than 25 years, and it has been upgrading and updating continuously and producing the different lead time forecast. Okay, so what does TIGI contain? So it contains the various weather parameters. I'll come back to you. How does the TIGI portal looks? So this is the TIGI data retrieval system where you can select the year and the months which are shown over here from 2006 to 2025. You can select any of the ensemble EPS, any centers data. So you will see here that China CMA, and I talked about the IMD Ensemble WF. So this is for our country. This is IMD. This is generated by India, and they are on the Google global platform with a different time scale of 0, 6, 12, 24 hours. Okay, so depending upon the availability of data of ECMWF or NCMRWF or JME, whether it is for 6 hours, 12 hours or 24 hours, you have to just click on it and you will be able to download this data. So this is the origin and time again shown 0, 6, 12 and 18, and select number. How many ensemble number the specific data have? So as I said that the ECMWF have a 50 members, so you have to click here on a 50. If we talk of NCMRWF, then it may have 11 or 22 members. Depending upon that, you have to click on that particular member. At the same time, thus time step that you want it for 1 day lead time, 2 day lead time, 3 day lead time. So here is the 24, 48 hours, 72 hours, and like that up to 15 days lead time, you can able to download the ensemble data for how many parameters. So you can see here there are 28 parameters. Yes, in this specific lecture, we will be focusing more on the floods, and therefore the total precipitation, you will see that I am talking about only about the ensemble precipitation forecast. Otherwise, you can have these 28 parameters, and any researcher working in the hydrology or in urban areas or in agriculture and wants soil moisture data, temperature data, right, or that of the mean sea level pressure data, they can able to download it from this portal, provided these data are uploaded on the portal. So you will be able to download the only that data which has been uploaded on this particular portal out of that of the 28 parameters. Okay, so after explaining you the data, that is ensemble precipitation data which we have downloaded from the TIGI portal, right? Now how to process that data? So here is the slide which shows that how the ensemble data extraction process continues. So we have TIGI data retrieval, ECMWF. Suppose if I am downloading ECMWF data, so I wrote it here, ECMWF portal, selection of the month, type, number of member, lead time and parameters that I have shown in my previous slide. Identification of latitude and longitude of the area. For example, I wanted to download it for the Surat. So I have to give the latitude longitude of the Surat. Grip file data that get it is generated into that this particular format. That format you have to convert into the Excel, and then afterwards you can what you can say, separate it out as this study. Specifically, I am going to show you one case study in the later part of this particular presentation. So I wrote it at 1 to 5 day lead time, but you can have the data up to 1 to 15 days lead time, right? So what are the other future opportunities with this ensemble precipitation data? That is machine learning plus TIGI, sub-seasonal to seasonal forecasting, high resolution ensembles, open source hydrological modeling, coupled atmospheric hydrology models, AI-based downscaling and bias corrections. So what is the importance of ensemble forecasting in hydrology? So improved forecast accuracy, as I said that the short duration intense rainfall is increasing. If we get this particular forecast information early, 4 days before or 5 years before, definitely we can save the damages. uncertainty quantification helps in understanding and quantifying the uncertainty in precipitation and stream flow forecast. Risk assessment provides probabilistic information for better risk management, resource management, climate change. Will help in adapting the climate change. So now I am showing you how the ensemble precipitation systems data has been applied and how a reservoir forecast be made. So I have taken example of the Sabarmati River basin. This is the basin map of the Sabarmati River, where we have considered the upper Sabarmati River and the Dharoi Dam. Here is the dam, which is the upper Sabarmati basin we have considered, and we have forecasted the inflows into the that is Dharoi Dam, which is located in the upper Sabarmati River basin. On the downstream side of this particular dam, there are two major cities of Gujarat and even the capital city, that Ahmedabad and Gandhinagar. So releases from the Dharoi Dam directly affects these particularly these two cities, wherein the millions of people live and get affected by flooding. Right. So this is typically a picture of the Dharoi Dam, which shows that it has completed in 1978. Height is approximately 58 meters, and the storage capacity is 1,496 million cubic meter, which shows that it is one of the major dams. Now, when we want to apply the ensemble precipitation data, how we can do that? So basically, there are two parts. If you will see on this part, that is ensemble precipitation data. If you look at this part, it is a hydrologic model, right? And what about this? This is the output of it, right? So, what is our basic purpose? We want to understand the stream inflow into the reservoir. That is our purpose, that is our aim, right? And therefore what I did, I used the ensemble precipitant data. Why I am using ensemble precipitant data? Because I want to understand how better this ensemble forecasting of 1 to 5 day lead time. In this present study, I have considered lead time up to 5 days. This can be up to 15 days. So what are the steps? The steps is that you have to download the data from the Tiki platform. In this particular study, we have downloaded the 5 centers data: ECMWF, NCEP, UKMO, IMD, and NCMRWF. Then what we did? We did the post-processing of row ensemble data at statistical analysis of post-processed data, and we did the bias correction. Once the precipitation data, which is downloaded from the TG platform, bias corrected, that we have given it to hydrological model. This hydrological model is not readily available. That you have to develop for your specific basin. Once you have developed that hydrological model, after developing model, calibrating model, and validating model, and you are sure that your hydrological model is producing a good results, then you can input the correct bias corrected ensemble precipitation data to your hydrological model, and you will have the forecast for 1 to 5 day lead time. Once you have forecast for 1 to 5 day lead time, you wanted to check how good it is. So therefore, the bootstrapping sampling, accidents of probability, hit and miss analysis, and range of probable inflows into the reservoir, that can be forecasted. So this entire process has been carried out in the subsequent slide that I will show you in the subsequent slides of Dharoi Dam. So whenever you do any modeling, you need a lot of data. This particular presentation I have prepared keeping in mind that a scientist from NCMRWF may be attending this particular webinar. At the same time, a BTech or a MTech student may be attending, or a field engineer, right? Research or fresh field engineer is attending or trying to carry out some work on this particular topic. So for their information, I have added this particular slide in my presentation, that the data requirements are hydrological, meteorological, and satellite data. Hydrological data includes discharge, water level, hydraulic structures, etc. The agencies from where we have collected this data: CWC Gandhinagar, SWDC Gandhinagar, Dharoi Dam, and field service. The meteorological data, that is rainfall and temperature, that we have collected from IMD Ahmedabad, NCMRWF IITM, SCWC Gandhinagar, ECMWF and CHRS data. The satellite data like DEM, LULC map, soil map, that has been collected from ISRO, Bhuvan, NRC, USGS, NASA, and Geological Survey of India, right? So this much of data is required for this modeling, right? So again, in this model, what is the difference between this slide and the previous slide? In this slide, I would try to show you the post-processing methods also. So the post-processing methods applied in this is BMA, CNLR, log regression, hololog, HXLR, and OLR. These methods are applied for post-processing of the precipitation data which we have used, and that has been given to that of the hydrologic model. Okay, so again the grid points, because what happens is that whenever you see the various study area, so in that study area you may be having the different data. So there are 4-5 events which we have studied for the Sabarmati River Basin, trying to check the accuracy of ensemble forecasting for Dharoi Dam, which is on Sabarmati River. Out of that, flood analysis of 2015 I am showing over here, wherein the peak flood was of 9,123 meter cube per second, 2.5 lakh cubic of water was released, and 1,500 people were evacuated. 20 billion property damages, 72 deaths were reported, and 81,609 cattle died during the, what you can say, 2015 flood event of Sabarmati River Basin. Approximately 2 lakh hectares of crops were failed. Okay, so these are some of the pictures of the flooding during flood event of 2015. This is of Ahmedabad city, where you can see that. Does it mean that we have to download only the data of that particular month? Yes, the monthly data is available. If suppose I am studying about the 2015 and the month was July, then from the TIGI portal I have to download the data of 2015 July month and do the entire process. The data downloaded resolution was 0.5 degree by 0.5 degree. Depending upon your grid size, the number of grid points that will fall in your study area. If your study area is large, the number of grid points will be more with a finer resolution, and that will lead to the calculations in terms download of in terms of crores of data. That is one thing. Secondly, for each member, for example, in CMWF one day, suppose you have downloaded 50 data, then you have 50 hydrographs. So your hydrological model is required to run for one day 50 times. Your event is for 30 days. That means 30 into 50, 1,500 times you are required to run your model. So you may ask me here, sir, this is a very time consuming and energy required job. Can anything be done for this? Yes, it is possible now to reduce the time as well as the energy which is required to run the ensemble prediction systems. So ensemble data processing, pre-processing, and that of the post-processing. This I have shown you that grip files downloaded for 4 centers data converted into the Excel file. Again, there are three stations we have considered: Dharoi, Kharaj, and Jotasan. And for these 3 stations, for 1 to 5 day lead time, the forecast has been developed. Okay, this is the slide which shows how the ensemble members looks. So data looks. So you can see here V12, that of the V50, right? That is ECMWF data for specifically one day, 1/7/2023, and this is against this is the observed data. So you will get such type of a file that you can process using any of the methods which are listed over here. We have used all the methods for post processing it, and then afterwards out of that we have selected the best method, that is CNLR method for our study area. For your study area it may be a different post processing methods which can be used. This particular post process data, how we can check that whether or how we can select, suppose I have gone for the 6 methods and out of that I have selected the CNLR method. So for that what I will do, I'll go for these 3 tabs: model fitting, model prediction and model verification, and out of that you can find it out using comparing the model verification result. You can choose the most suitable post processing method for your particular study area. This shows the comparison of, this is a very beautiful slide which makes the understanding of ensemble precipitation easier. You can see here there are 3 colors. One is blue color, another one is row ensemble orange color, and third one is yellow, I can say, right? That is CNLR post process ensembles. So you will see that the observed rainfall values are in blue, while that of rows ensembles are in what you can say orange, and they are very high compared to that of the what you can say blue values, and therefore we recommend that the post processing of that data is required. And by doing that post processing, you can see these yellow towers, yellow lines, which are very close to that of the observed rainfall, right? So this way the post processing helps in reducing the biases and that of the uncertainties in the ensemble data. Okay, so hydrological model, as I said, that we have used HMS, and that HMS model required these steps for the development of hydrological model, series of maps, right from digital elevation map to that of the hydrological soil group. Once the model is developed, right, again you will see the grid points which are lying in your study area. That also you have to check. Depending upon there, your work will increase. If it is a final resolution, more grid points may be there, more ensemble data may be required, more, that data is required to be post processed. The basin is divided into number of sub basins over here, and the rainfall map is also prepared, drainage density map is also prepared, right? And then the ensemble forecast that has been input into the hydrological model to get it the runoff. These are the data which gives that during 2015 flood from 21 to 3 at 2015, how much rainfall has been received by the 2 stations which are upstream of the Dharoi Dam. So Dharoi Dam itself, one station is on Dharoi Dam, another one is Jotasan, third one is that of the Kharuj. And you can see here this 21 to 3rd, the amount of rainfall received is equivalent to its annual average rainfall, that is 750 mm. That's why it has led to flooding. Okay, so this is observed precipitation graph for 2015 event that has been given to hydrologic model here HMS, and that HMS model is also required to be calibrated and validated. Therefore, specifically I have kept over, not only kept only one graph of 2015 flood event, but the other flood events also. This is for 2015 flood event, observed and simulated rainfall with R square is equal to 0.91. Though R square is 0.91, it may be okay academically, but it is not acceptable when you are applying this particular model to any of the dam. The CWC expects around 0.99 R square. Up to that, your model should give, model accuracy should be, and then such models can be used for what we can say inflow forecasting or for the releases. Meaning here higher accuracy is the better. R square equal 0.91 is not that good. Okay, then comes the 2017 where the R square accuracy comes out to be 0.97. For 2098 19, it is again r square 0.92, right? And these three slides signifies the importance of your hydrological model which you have developed for your basing. Your forecast accuracy depends upon the fine tuning of your hydrological model also, apart from the ensemble precipitation data which you input into your model. This specific lines which I have mentioned is for those who are practicing and developing hydrological model for basins like Krishna Basin, Kaveri Basin, right, or Tapi Basin. So for them, these three particular slides and these lines which I just mentioned are very, very significant from the practical point of view. You cannot have a model with r square of 0.8 and that you are using on any of the dam site. Strictly, I will say that that should be discouraged. Okay, so this is again, that was all a hydrological model. Means we finished two steps. Number one, downloading of the precipitation data, ensemble precipitation data, right? That is from the TIGI website, or you have got this from what you can say that NCMRWF or IMD, right? Now that post-process data been input into your hydrologic model. For what purpose? To have 1 to 5 day lead time forecast. Okay, so this ensemble model prediction, after putting it, this is one of the simplest what you can say graph which I have drawn for ensemble member 1 day lead time flood forecast for ECMWF centers data. And there you can see that the observed line, that is the black one, while the one member V50 that has predicted the highest inflow, that is 9,989, while that is U11 which has predicted 1,100 QMAX. So as I say, how the deterministic forecast differs from that of the ensemble predictions. Here you will get the range of forecast, and here I have only considered two members. What I mean by range of forecast, suppose if I take this particular peak which was observed on 29th of July, if I consider that this is the 29th of July, the maximum inflow into the reservoir observed was 9,989 cumac. Then how my forecast, right, ensemble forecast predicted, whether they have predicted well, whether they have predicted poor, that we will see in the what you can say the next slides. Okay, so we'll go for the next slide. Now this shows the complete set of ECMWF, NCAP, UKMO data with 1 day lead time for 2015 flood events, wherein you can see that V50 means that is all about ECMWF forecast, and N1 to N22 20, that is for NCMRWF forecast, and U1 to U11 that is for UKMO forecast. So that was for 1 day, then 2 day, then 3 day, then 4 day, then 5 day lead time for NCMRWF data. And this is all what you can say ensemble info prediction 2015 event 1 to 5 day lead time. You will see, sir, हमको इसमें कुछ समझ नहीं आया, right? What you are talking about, those who are working in this area, that they have definitely understood what I am trying to present. But those who are maybe first time looking at this ensemble info prediction, for them I have made it further simple, right? So here you see, now please pay attention. Even if you have not paid attention throughout the what you can say presentation, please pay attention, and this will make you very much clear that how ensemble forecasting helps, right? So on my left hand side, I have observed inflow 2015, while that is the bottom graph. This is where my pointer is. Then this is the inflow prediction by best ensemble member of ECMWF data for 1 to 5 day lead time. what I am talking about the lead time, since from beginning of the lecture I am saying that the forecast is available up to 24 hours, that is deterministic forecast, which is issued by IMD. IMD is now also issuing up to 3 days and up to 5 days in certain areas. Forecasts are issued by IMD up to 5 days also. ECMWF, that is ensemble forecast, can be up to 15 days, right? In my study at present, I have used 5 days. So what does it mean? So just you see here that this is 22 July, and here 22, 23rd, 24, 25, 26, 27, 28. If you see over here, this is 22, 23, 24, 25, 26, 27, and 28. Okay, so what does exactly this means? So if I am doing forecast on 22 July, 22 July, right, for 22 July itself, then 22 July, 23rd July, that is 1 day lead time. On 22 July, I am doing for 24th July, that is 2 day lead time. 22 July, I am forecasting for 25, that is 3 day, and that is 5th day. If I consider this as a 1 day, then this 1 day, 2 day, 3 day, 4 day, and 5 day forecast. That means on 22, I am forecasting what will be the inflow in the reservoir on 26 July. This what I have explained completely up till now. Outcome of that is I am showing you now, that you downloaded the data, you post-processed the data, you prepared the hydrologic model, you calibrated, validated the hydrologic model, you input the ensemble data, ensemble precipitation data into the hydrologic model, and you got the runoff. Okay, so that runoffs, as I have taken 5 day lead time data, if I have taken up to 15 days, so 22 plus 15, I would have up to 8 August. Probably I can do forecast from 22 to that of the 8 August. So in this study, 5 days. So that's why 1, 2, 3, 4, and 5. You may ask me, sir, fine, we understood this, but how does it work? We are still not able to follow that what you have done is actually helpful or not. So for that, I'll be showing you over here that how it's going to helpful. So here, this is the peak inflow, right? This left-hand side top graph, you will see that oval shaped circle has appeared. Okay, now that oval shaped circle is of 29 July. Please pay attention. If you miss this, probably you will not understand what I mean by ensemble forecasting. So this is my 29 July. On this line, this is the line which is on the top where the values are marked. They are actual inflows into the dam on that particular day. For example, on 29 July, what was the observed inflow? 9,123. Right, that was the observed inflow. Now you come to 25th July, and on 25th July, just see how much inflow the ensemble forecasting system data, ECMWF data set has forecasted, that is 8,020. If you will see on 26, it is 7,036. On 27, they said that 9,000, right? QSAC data, that 9,000 QMAC, probably this is in QMAC data, that much will be the what you can say the inflow into the reservoir. Then on 28 again, the accuracy, 1 day's accuracy is increased. That means the dam operator is aware 4 days before there will be high inflow into the dam, and accordingly he will be ready for releases, right? Or he will, suppose if he is not taking any action, then also he will be mentally prepared that if this much will be the inflow, I have to release this much of water. He may inform the downstream villages, he may inform the collector that, sir, this much of there is a possibility of such a huge releases in the downstream side. You may keep your man and material ready to evacuate the people or to move the people from to the safer place. So that is the advantage of ECM. Similarly, you can see for NCEP data, and you can see for UKMO data, right? So the forecast on the same date you can compare and check that how much close it is to that of the observed data, right? Again, the color code is also given over. Green shows the very heavy, so very heavy inflow is there. So after showing this, right, what is the future scope of the research? So you can expand this to the other basin, incorporation of climate change scenarios, distributed hydrologic models, improvement of long-term forecast, refinement of post-processing techniques, real-time system integrations, use of multi-ensemble model. In the beginning, if you will remember, I say crores of data has been processed for this particular site. To reach up to this particular site, the crores of data were processed. 2,500 times for these flood events, 4 or 5 flood events which we have considered. 2,500 times we run the hydrologic model. That has been done by Dr. Anand Patel, assistant professor, Nirma University. 2,500 times he run the hydrologic model. You will say, sir, this is a very clumsy, time consuming and energy required process. Yes, but if you will again go to the ECMWF, Europe, who are the pioneer of ensemble forecasting, they have come with artificial intelligence forecasting system ensembles, where they can do this entire process fast and which requires the less time as well as the less energy. So this can be combined with this ensemble forecasting system with artificial intelligence. There is a big, huge scope of work for everyone, whether it is a BTech student, MTech student, scientist, or a field engineer. There is a huge scope of this which can be used in the field of ensemble forecasting, not only from research point of view, not only from consultancy point of view, but it will be a great service to mankind. As I have shown in Banas River flood in 2017, 1,650 crore damage, right? Around 1,500 cattle died and 200 human beings died in 2017 flood. So if you want to prevent such disasters in future, we need a very good forecasting system which gives us the early warning, that is 5 day 10 day in advance, so that we can prevent such huge losses to the property and life. These are the publications which I have included in my presentation, so that you should not run here and there in case if you wanted to do some work on this, or those practicing engineers and developing the models, they can refer this paper and definitely they will have some hint out of this to improve their real-time models, right? This is the paper which is in American Society of Civil Engineering Journal, which reviews the ensemble-based forecasting specifically for reservoir operation, and hundreds of studies we have compiled into it that which are globally available, and how they are using ensemble-based forecast for reservoir operations. This is another papers which are again published specifically. I will mention this one, which will be soon online, which will help you to understand how the control forecast and ensemble forecast differ each other. And we have carried out both the forecasting using the control forecast and forecasting using, that is reservoir operation inflow prediction using control forecast, and reservoir inflow prediction using that of the ensemble forecast. So thank you very much. This is the research and consultancy collaboration. You can hit me up on LinkedIn. That is my profile, Dr. SM Yadav. You may see me on Instagram with Professor SM Yadav. And if you are not able to ask me any question right now, you can WhatsApp me on this particular number. My aim and Manish's aim is that we should improve our hydrological forecasting, early warning. And if you can do that, as I said, that will be a great service to mankind or human beings. Thank you so much. And this,
I think we have few queries. We can start with that. We will take the first question. Sir, how you define flood in your study have you defined flood which water level over top river bank, or have you defined any threshold to classify flood or non-flood event? If you have use threshold, how you have determined threshold? Professor Saab.
Yeah. So this is a practical question. The one who is asking this may be a field engineer or working in the field. Probably this happens because, as I said, that this methodology you can apply to another river basin also. So the best is like what we have done in case of Ukai Reservoir. From the downstream of Ukai Reservoir up to the sea, that is 100 kilometer of stretch, the Surat municipal has gone for survey, and they had a cross sections, actual cross sections, and based on that we have decided the carrying capacity of the river. So the answer to this question is you can go for the river cross sections, and based on the river cross section you can find it out what is the maximum carrying capacity of the river, and depending upon that you can decide the threshold value of your discharge.
Okay. Next question, sir. Some hint cast ensemble member may match well for one event and same member may not for another event. Then how will we carry forward this to forecast mode?
That's what I was saying, that the hydrological model which you have developed for your specific region, in this study also we have taken 5 centers data, and then afterwards we have analyzed out of that the centers data which is considered to be a good, that is suitable for your study region, right? But this will not happen. This is again a long term process. You have to select one specific basin, and in that basin you have to keep on what we can say analyzing for a few years, and based on that you have to fine tune your hydrological model, your post processing techniques, and that will finally tell you yes, this particular center's data is good for you. Here I consider that there is a doubt in the person who is asking this question. I want to clear that doubt also. This specific technique is successfully used by European countries. So suppose if you are in a London, you are moving out of the house, and they watch the TV, and on TV it is said that at 4 p.m. there will be rain, and will be rain in the city. Why this happens? Because their models are that much trained, that and numerical models are so good that they do the prediction correctly. So you have to train your model, you have to develop your model such that it gives you the correct answer.
I think Mr. Ranjit has continued with this query. Sir, with ensemble data, say 25%, dependable forecast is say 100%, 50%, dependable forecast is say 50, 90% dependable forecast is say 10, then which value to consider? Will this add to indecisiveness?
Yeah. So Ranjit, are you from India? If he is from India, then in most of the reservoir case, we are taking 75% dependable flow for the reservoir. But what he is talking of is maybe talking about the reservoir under planning. In case of reservoir which are actually constructed, we want to go for the forecasting. So when we are going for forecasting, everything is set because the rule level is known, the water level is known, there is a rainfall in the basin. Based on that there will be inflow into the reservoir, and depending upon that we will be doing the gate operations, right? So what he may be talking is maybe talking about the new reservoir or new planning. But if you want to apply this for the existing reservoir, probably you have to look it into the day on which the dam is full, how much water is that, what is the rule level, how much is the inflow into the reservoir, how much the reservoir can store, and how much you can release. So there is no probability, sir. Here all the values are fixed, that the inflow is coming from hydrological model, that you are giving it to your reservoir. Based on that your water level is rising, based on that the operator is operating the gates.
He's saying, sir, about ensemble dependable forecast.
That's what I am saying, that this is the forecast. Though it is ensemble based, we will say that it all depends upon the inflow into the reservoir based on your real real-time data of rainfall and inflow into the reservoir, right? It is not like that you are doing some randomly taking some data and then you are considering that there is a 75% inflow into the reservoir. That is not associated with that of the ensemble forecast. Ensemble forecast will give you what will be the precipitation after one day at your particular grid point. It is not saying that it is 75% dependable or 50% dependable or 100% dependable. Ask him to try to contact me on my WhatsApp number. I will make it things clear more to him.
Okay, next question from Manjusa ma'am. How are you fetching the data on real-time basis?
How do you mean to say that the rainfall data, the rain? See, Manjusha ma'am, the problem here is the calibration and validation of model. So that calibration and validation of model we are doing, like say for example Sabarmati river, we use five events, and from the 5 events we found that the ECMWF is the data center which the forecast of which 1 to 5 days is good, right? Then we'll be using that forecast for the future forecast, right? For example, today is 8th of March and you want that up to 12th of March what will be my inflow. So in that case, my calibrated and validated model, I will simply input the post process forecast of 8 to 13 days into my model, and that will give me this, which this will be the, what you can say, the inflow, that this much inflow will be there in the reservoir. So most important and necessary condition is your model should be well calibrated, well validated, well developed, and again the center's data which you are using for it, that also you have to stamp that this particular center's data is good for my basin or my river.
Next question from Manjusa ma'am. How can we replicate in rivers where cross section changes after every monsoon?
Yeah, that's a problem because we probably our rivers which are from central UP, right, or Uttar Pradesh, the rivers which flows from Himalayas, and when it enters into the plain of Uttar Pradesh, the slope is hardly 11 centimeter in 1 kilometer. So that's having a very less slope. In that case, the river keep on changing its courses every time. Okay, so the depth will remain uncertain. What here we are talking about is the forecasting. At least if you'll forget that the river is changing course, what we can predict is, because of this much of rainfall, this much of runoff is about to pass through a particular station, discharge station, right? That we can say confidently. Rest, that changing of the course of the river, that is required to be studied at that particular, what we can say, river and the location. I have been expert for government of Uttar Pradesh for 5 years. I have designed the dredge channel of 8 to 10 kilometers at 25 locations, which passed the flood water safely, where the river was changing course and affecting its either right bank or left bank. So it is a localized solution that you have to find it out for. However, the flow you can, for such river which are changing the courses, for that also you can predict the inflows at particular gauging sites based on the rainfall.
I will take the next question. Sir, have you worked on coastal flood inundation? If so, please let me know where I can get tide gauge data, as PSMSL have data only for few stations. I am talking in the context of Andhra Pradesh. Mr. Sravanthi Karnata has asked this question.
Ask him. Please note down my mobile number 94261. I'll write in chat box, and please message me there.
Okay. We'll take the next question. INCOIS, you need to contact for observed tidal data. Somebody replied, "Dear sir, the inflow will have uncertainty that comes into the reservoir, but most of them follow static rule curve for releasing water, which is incorrect because the dynamics are changing over period of time. So most of the dams reservoirs should follow dynamic rule curves. Please answer.
this is this is an administrative problem, administrative question. Who has asked this question? What's his
I
name?
think
Varun.
Mr. Shiva.
Shiva, Mr. Shiva, we are in such a country where it is very difficult to go for dynamic rule. Yes, Australia they have done. I know the Brisbane was inundated 3 times. There is a dam upstream of the Brisbane city, which was only for flood storage, and that has been kept 50% what we can say empty for inflows. In one season, the flood came and it inundated the Brisbane city. They have made it half fill. Out of 50%, 75% they left for flood storage. Only 25 storage they made into the dam. That also flooded the Brisbane city. Then further they reduced, right? That also the flooded the Brisbane city. So that was dynamic rule curve. What you are saying that has been followed in Australia, but that has not solved the problem of what you can say flooding of the Brisbane city. You can refer and read it. Okay, but the problem in our country is different. Our dams are basically for water supply and agriculture purpose. I tell you, in case of Ukai Dam, the canal network is 40 years old, and some of the canal network is 50 years old. Recently, they have decided for renovation of this canal network, and they said that they will not supply water for 1 month. And there was agitation, fund is available, designs are made, tenders are about to float, and the authority has to drop that particular work. What is the reason? The agitations from the farmers which are growing crops, and they said that no, canal network is good and you cannot stop release of water to us. So in country like India, definitely the day will come, not today, tomorrow. People will understand, the farmer will understand the significance of the dynamic rule curve, and they will follow it.
I think we are finished with the question. Thank you, all the
Thank you,
dear
sir.
participants, to ask this question, and thank you, Professor Saab, for
Thank you,
wonderful
sir. Thank you.
session. And
Thank you,
I
sir.
think it was the one of the most engaging session. Also, most of the people I have asked, and you have clearly cleared their doubts too. And
Sure,
finally,
sir. Sure, sir.
we are concluding this session. Thank you, Professor
Thank
Saab.
you, sir.
Thank you,
Thank you
all
so
the
much.
listeners,
Thank you.
and
Thank
special
you.
thanks to our uh, uh, I think woman speaker today,
Participants, yes, yes.
Miss Swati Kausalji,
Ji,
for
ji.
delivering a message to our community. And from our platform, we would like to say Happy Women's Day to all the special ladies who are here and across the India and across the world. Good wishes to all. They do well. They keep achieving. They keep rocking. Our best is wishes for them. And also, finally, I would like to thank the team members who put lot of efforts day and night to curate this session. Mr. Naveen and also Mr. Dheeraj and Sunil, they are working in the background to make this kind of session happen so that people are enjoying and uh, mm, uh, trying to learn and gain from each other. Thank you so much, Professor Saab, and thank you all for joining.
Thank you, sir.
Take care.
Thank you,
Goodbye.
team.
See you.
Sir.
Bye-bye.
Good night. Good
Thank
night.
you.
Thank you, Professor Saab, and thank you, Manish ji.
Yes, sir.
Yes, sir.
Thank you very much for hosting this kind of events.
Thank
Here,
you.
Dr.
Thank you, sir.
Nagaraj Patil from VTU Belgavi.
Yes, sir. Thank you. Thank you, sir. Thank you very much.
Your efforts are too much, sir. Thank you.
Thank you very much, sir. Namaskar, sir. Thank you.